This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is video 20 in our series of solving equations with decimals. Getting a little more complicated here. So we can do it two ways. We could just work with the decimals as they are, or we could eliminate all the decimals in step one. That's how I'm going to do this one. I notice there are three decimals, right? 0.03, 0.02, and 0.03, and there's one in each term. So I'm going to multiply both sides of the equation by 100, so I get to move those decimals all two to the right. So when you multiply everything by 100 on both sides of the equation, you'll just get 3 times x plus 7 minus 2 times the 5 minus x equals 3, because when you multiply by the 100, that means all the decimals, each term gets 2 to the right. Make sure you don't also multiply inside the parentheses, because that's all part of this one single term. So now we have an equation without decimals, which is usually easier for most people to solve. So let's go ahead and finish. Actually, you could finish from here probably pretty easily. So we have 3x plus 21. Remember to distribute your minus sign here, so it's a negative 2 times 5 minus 10, and a negative 2 times a negative x is a plus 2x. And then we'll just combine like terms over here. 3x plus 2x is 5x, plus 21 minus 10 is 11, equals 3. And subtract 11 from both sides. So I get x equals negative 8/5. Darn, it'd be nice if it was a whole number. All right, now let's solve this problem. Not worrying about the decimals, just being careful with our arithmetic with decimals. So we're going to distribute this 0.03 to the first parentheses, so that'll be 0.03x plus, and then 0.03 times 7. Well, what's that? You do 3 times 7, which is 21, and then you have to move the decimal in two places. Hey, by the way, you might want to put the video on pause and try this all on your own first. Minus, okay, now we're going to distribute the 0.02, but it's also the minus sign we're distributing. So we have 0.02 times 5. All right, so how do you do that? 2 times 5 is 10, and then you have to move your decimal in. So that's 0.10. And then I have the, check this out, I got a minus 0.02 times a minus x, so that's going to be a plus 0.02x. So you can see when you're leaving the decimals, you just have to be very careful with all these decimal points everywhere. Okay, now let's simplify. At this point, by the way, you can multiply everything by 100 and move your decimal point, or you could just keep working with the decimal points. So if I were going to combine like terms here, I've got, here's the 0.03x and the 0.02x, that's going to give me a 0.05x. And I've got 0.21 minus 0.10, so that's 0.11 equals 0.03. And then we could subtract 0.11 from both sides. Now we got to be careful with both decimals and the fact we're adding a positive and a negative sign, so they're a positive and negative number, so it's going to be negative. And then 0.11 minus 0.03 is 0.08. So I have 0.05x equals 0.08. And then we could divide by 0.05. And that gives us a negative. Now we'd have to move the decimal 2 to the right. And we're going to get negative 8/5. Now, you could do a little combination here. You could go ahead and do your distributive property first and then multiply everything by 100. Let's see what that looks like. So let's say you did the distributive property first, like we started that problem. But at this point, we see there's every single term happens to have 2 decimal points. So why not multiply everything by 100, meaning everything gets to move 2 spaces, 2 decimal points to the right, every single term. And then you get a little bit easier numbers to deal with right here. Okay? And from this point, it looks like the same way I did the first problem. We combine like terms. The 5x plus 11 equals 3. And we get 5x equals negative 8. So here we are again with our x equaling negative 8/5, right, after you divide by 5. Okay, so 3 ways you could, there's more ways, not everybody does it exactly the same way. Checking the answer is actually the hardest part of this problem, but we got to do it. And by the way, this could be written in decimal form too, because negative 8/5 is negative 1 3/5, right? And 3/5 is negative 1.6. So when you check your answer, you could put in negative 8/5, or you could put in negative 1.6. Since the original problem has all decimals, I'm going to use the negative 1.6. So we've got 0.03 times negative 1.6 plus 7 minus 0.02 times 5 minus negative 1.6. All right, and we have to simplify this side, so we've got 0.03 times. Now we've got 7 minus 1.6. That's going to be 5.4. Remember, you're adding a positive and a negative, so you're going to have to, you could go out on the side and do 7.0 minus 1.6. You're going to get 5.4. And over on the right, we've got 5 minus a negative 1.6, so that's going to be the same thing as 5 plus 1.6. That's going to give me a 6.6. And then we have to multiply 0.03 times 5.4. So we've got to do 54 times 3. I'm going to do that in my calculator, which is 162. And then I've got 3 decimal points to go in. So it's 0.162 minus, and then I've got to do 0.02 times 6.6, so that's just 2 times 66. That's 132. And I get to go in 2 decimal places. That doesn't look like it's going to equal 0.03. I wonder where I made my mistake. Oh, wait a minute. Yes, it does. I was thinking this was a negative sign. So 0.162 minus 0.132 actually is 0.03. That's a relief. Okay, so 0.03 on this side, 0.03 on that side. Yes. So certainly that is a correct solution. And we've checked it with a decimal. Just for fun, let's go ahead and try it with the negative 8/5. All right, let's put in negative 8/5. So we've got 0.03 times, I'm going to put in negative 8/5. Now, I'm going to have to add that to this number 7, so I want to write that with a common denominator. So I want that to also be fifths, and that's 35/5. Remember, you can do 7 over 1 and then times 5 over 5. And then over here, let's say I'm going to have to do 5 minus x, so I'm just going to note that I'm going to have to get a common denominator for this 5 as well. I'm going to try to get it into fifths, 25/5. And that should make sense. 25 divided by 5 is 5. 35 divided by 5 is 7. So yeah, that should work out just fine. Minus a negative 8/5. Okay, so we're going to simplify inside parentheses first. So I have negative 8 plus 35. That's 27 fifths minus, and over here we've got 0.02. I've got 25 minus a negative 8. That's 25 plus 8, 33 fifths. Now you can leave these decimals 0.03 and 0.02 as they are, or you could also write those as fractions. It's really up to you. I'm going to go ahead and just leave it as is, and I have 0.03 times 27. That's, let's see, 3 times 27 is 81, and then I have to move the decimal in, so I've got 0.81 over 5 minus, then I'm going to do 2 times 33, that's 66, that's over 5. So I've got to do 0.81 minus 0.66, that's 0.15 over 5. Wow, it's going to work. And then there's a whole number, so 15 divided by 5 is 3. And you move your decimal in 1, and we got 0.03 again. Whew! Man, that's a lot of arithmetic there. It checks. Therefore, this is the correct answer. So we've got negative 8 fifths. Like I said, checking a lot of times is harder than just doing the original problem. So you've got, might be a good idea to try solving this equation all on your own and try checking it again on your own as well.